application software was actually a lot easier earlier. You wrote software, you wrote some tests, and then it worked the same every time. Like it was always reliable. It did exactly what you programmed it to do, right? Now, not so much. Program it to do something, then it might do that, or it might not, right? And so now you have to build, at the application layer, you have to engineer reliability. You have to have eval. You have to have a feedback loop of like, if the user asked it to do X, did it actually do X or did it do something else, right? So you need a whole sort of analysis and evaluation infrastructure. Attribute-based access control actually allows you to have dynamic policy-driven access control that's based on decisions dynamically rather than some pre-baked set of roles. So I think it is the better model. Yeah. But coming up with a way for attribute-based access control to be standardized across products and companies, very hard problem. So we'll see how that plays out. You have to like basically introduce this notion of LLMs judging other LLMs, agents judging other agents. Right? Some of that you can bake into your production workflow. So you can have a agent that does some work, you take the output of that work, and you have another agent evaluate that work. Yeah. And if it's not good enough, you make it look back.
Hey, welcome to the ScaleKit podcast. I'm Ravi, one of the co-founders of ScaleKit. ScaleKit is an auth stack for AI applications. Today, I'm thrilled to be joined by Mrinal Wadhwa, co-founder and CTO at Autonomy, a platform as a service for distributed agentic AI systems. Before co-founding Autonomy, Mrinal was CTO at Fiber, where he built IoT platforms. He specialized in distributed systems and applied cryptography at massive scale. Expertise that's now essential as agents become autonomous actors. Mrinal, excited to have you here.
Glad to be here. Thank you for having me, Ravi.
Mrinal, before we talk about autonomy and all that, so how do you think the whole building software for agents or building agents has changed dramatically over the last decades of building desktop applications and then web applications and then mobile applications, and then now we're writing autonomous applications?
Yeah, really good question. So I think software and product building is like fundamentally changing right now. So, if I think about it, agents are different. One, they're driven by LLMs, so they're non-deterministic in both their outputs and their actions. So that's a key difference. The other big difference is traditionally we built software to be driven by like form fields, right? You clicked a button, an API request happened, some small thing happened on the server, like a database lookup, and you got a response and you were done, right? And this whole process took a few milliseconds. Like if you're good at building software, like 10 milliseconds, right? And most of it is just the round trip time. So that was the past. Now we click a button or send a chat message, and then the request goes to the server, and the thing works for minutes or hours or sometimes days, and it's this like long running thing, right? So that is different. It's non-deterministic, it's long running. It's also different because it's very kind of streaming oriented. Right? You're not sending a request, getting a response. Sending a request and getting a whole series of responses over a long period of time.
It's almost like a conversation between a human and a machine that's constantly happening, where a human asks a question and then machine, hey, these are my initial thoughts, but I'm still processing this and I'm doing this and I'm doing this. And this is how they're constantly streaming, not only their reasoning, but also the responses partially. Is it what you mean? Or
Yeah, that's a really good analogy. I would wager that building agents is more similar to building a chat system like WhatsApp or a streaming system like, video communication like we're doing right now. It's more similar to that than it is to building a SaaS application, right? So agentic apps are closer to this type of software. And what's different is, in the past, I think only like 10% of the software building community built this type of software. Very few people build WhatsApp or Zoom or things like that. Most people built form-based three-tier web apps, right? But now I think it's going to flip. Most people will have to build streaming, real-time distributed systems, and that's fundamentally different. Not only that, and you use this example of like humans are talking to machines, but it's also, we're building for this autonomous world. So it's also agents and machines talking to other machines that is also a bi-directional streaming conversation. And this is like a fundamentally different class of software that only a few people with systems engineering and distributed systems background used to build. But now most people have to build this new kind of software. And so I think we're in a fundamentally different world in terms of engineering. And I also think like software engineering is getting harder, not easier, which I think is counterintuitive at the moment because you can just generate a whole bunch of code. I think that's how those are some elements of like what's different now.
Again, a couple of questions from that. I know that you mentioned LLMs are generating code, which is supposed to mean that writing software must be easy. But I think what is happening is writing application software is easy, but the systems part of it is becoming harder because of all the challenges that you spoke about. Some of the challenges is about if actually two agents are autonomous, number one, how do they discover each other? And once they discover, how do they trust each other? And once they trust each other, how do they constantly establish their trust and then communicate with each other about their skills and capabilities and use those skills to perform certain tasks that they're organized to do? So how do you think this part is evolving when there are autonomous agents that are working together to solve a problem?
Yeah, really good question. I'll also challenge the part about application software is getting easier. So let me touch on that first, and then I'll come to the what's how systems changing. So application software was actually a lot easier earlier. You wrote software, you wrote some tests, and then it worked the same every time. Like it was always reliable. It did exactly what you programmed it to do, right? Now, not so much. Program it to do something, then it might do that, or it might not, right? And so now you have to build, at the application layer, you have to engineer reliability. You have to have eval. You have to have a feedback loop of like, if the user asked it to do X, did it actually do X or did it do something else, right? So you need a whole sort of analysis and evaluation infrastructure. So I think app software is also getting, in terms of like making reliable tools, getting harder. But yes, generating code is getting easier, which is I think a chunk of time software engineers used to spend, but a lot of it is engineering, architecture, design. Those parts are getting harder, even at the app layer. But to your question about like the systems layer, the challenges are the scale is kind of exploding, right? The scale of what we used to do versus scale of what we have to do now is exploding, right? So I'll illustrate this with an example. If you have a system where a button gets clicked on the UI, a request goes to the server, some database queries happen, and a response is sent, you're only spending a few milliseconds on the server.
Right.
And you can have, if you have 10,000 users of your product, all 10,000 of them only need a few milliseconds on the server, right? In terms of compute. So you can build a single server and you can support 10,000 clients on a little server, right? But if you are building agents, an agent is taking minutes, hours, or sometimes days of compute time on a machine. The machine's occupied. It's taking space. The agent is there doing something. There is no room for another customer there. And so now, time sharing compute is a harder problem. If you have 10,000 customers to support, it probably can't be easily fit unless you engineer the system to handle it properly in one machine. State is long-lived, right? That server, in fact, we used to delegate state off to clients. Like we would do session variables, and we like no state on the server, stateless servers, serverless systems. These were all kind of stateless things, right? But now an agent has long-term state. So you need a primitive and a mechanism to think about state for a very, very long period of time. This is just harder engineering, right? And so fundamentally how to build software is changing. And then comes the problem of like collaboration and getting agents to talk to other agents to talk to other existing systems. And that also, opens up this whole can of worms around how do you do trust? It's bi-directional. So earlier, we used to be able to get away with, unidirectional API request type workflows, but now it's a bidirectional flow. In fact, I think that's why MCP made a big leap forward, is because they were like, no. The request response paradigm of HTTP is not a good fit. We need a bidirectional streaming channel to tools, right? And that's what they did with the MCP design. So I think that's a big leap forward. But there's a whole collection of problems that need to be tackled better now.
Yeah. So Mrinal, I understand that when the whole web started, when the whole HTTP was introduced, it was predominantly unidirectional. But then you have bunch of WebSockets to enable bidirectional communication. You have SSE. When all these are around, why can't we use some of the technology that is used there for building bidirectional communicating agents for the same thing? Do you think they don't fit well for this paradigm of agents communicating with each other?
I think they fit well. I think bidirectional protocols fit well. So we have TCP, we have WebSockets at a slightly higher level. And I think MCP is just a set of primitives on top of that layer. But fundamentally, it's leveraging this bidirectional communication capability. And I think I see MCP and A2A and all these tools as like layers above this fundamental bidirectional protocol. But building a bidirectionally communicating system is just fundamentally harder. You now need session state on both sides of that communication. You now need to think about order of messages. So protocols like TCP tackle that and gave us primitives to think about order, but you have to think about buffers on both sides. You have to think about those buffers can't run out. Like it's just harder engineering compared to I sent a request, I had some little box JSON object in memory for a few milliseconds, and then I threw the object away, right? It was much, much simpler, not so much in this like new world.
Yeah, it's a very interesting topic. Now I'm very, very curious to understand what are you guys doing to make the whole infra for scaling this agentic applications and deployment much easier and better for engineers?
Right. Great question. Thank you. Many years ago, I started working on distributed systems of various kinds about 20-ish years ago. When I was doing that, I discovered learned about a programming language called Erlang at the time. And Erlang is very popular in telecom systems. It came from Ericsson, and it's based on this fundamental idea called the actor model that originated with Carl Hewitt in the 1960s. But actors are a very lightweight, stateful, concurrent object in memory. And so if you think about it, like, you have the OS. Inside the OS, you have processes. And inside a process, you have threads. And usually most software engineers kind of maybe touch threads once in a while, but mostly they don't, right? But in this new world of like having stateful concurrent things, we need to think about concurrency and communication in a concurrent way. So actors are an even smaller unit. So an actor can be a concurrent unit, and you can have like 10,000 actors inside one thread, or even like 1,000,000 actors inside one thread, depending on the RAM you have available in the machine. So this primitive of an actor is incredibly powerful when you have concurrent systems. So when I talked about like software engineering now is a lot more like WhatsApp, that's a good analogy because WhatsApp is written in Erlang. It's written in Erlang, and because you have all these concurrent entities sending each other messages and it needs state, Erlang is a really good tool to scale that type of system. In fact, if you read stories about how a WhatsApp team scale themselves, they write a lot about what type of engineering is involved. Similarly, Discord is written in Elixir, which is a language that runs on the Erlang runtime, right? So this primitive of actors is a really good primitive for building long-lived, stateful, concurrent streaming messaging systems. And turns out agents are like that. Agents are long-lived state. You need a lot of them concurrently working to serve your many customers. And you need to stream messages between humans and agents and other agents, etc. So at Occam, what we've done is we built Occam was our previous, is an open source project I started in 2020. And what we did is we built a streaming encrypted messaging system. At Autonomy, which is the company and product we've just launched, we have taken that core encrypted messaging capability, and we've built a actor runtime primitive around it that allows anyone to build and scale massively parallel distributed fleets of agents that can collaborate with each other and with other systems.
This is very interesting. So a few follow-up questions, Mrinal, there. So if I'm building my own personal agents out of LangChain or whatever, so how do I use your runtime to run these multiple versions of these agents so that, maybe I have one email summary agent, I have another agent or whatever, they're running for myself. I may also want to run them for Maybe I'm building a business, so I may want to run them for my customers who want to use them. So how do I deploy them? How do I use your autonomy platform to actually run this fleet of agents?
Yeah, great question. So I think the framing of the question is really insightful. It's one thing to build an agent for yourself because you don't need to think about separating state between your customers. You don't have to you just have one, you really have one agent, right? And you have one stateful thing. The scope of security is just you. The scope of the state is just you, etc. But the moment you take that and you go, I want to build a product that will service a lot of customers, then a whole can of worm of questions open up. One, you need to be a multi-tenant system. You need to have state that is partitioned. So you don't need one agent, you need one agent per customer, really.
Yeah.
Right? Even if you're just one agent use case, but actually, really, most applications need multiple agents to do different little things. So you end up very quickly from I am building a simple agent in something like LangChain to I need to build a concurrent system where every customer is being serviced concurrently. And each customer's agent has its own internal state. Each customer's agent has its own internal security boundary. And we don't leak data from one customer to another customer. Each customer will give us credentials to some tools. We need to make sure that those tools are scoped to that customer and we don't end up giving email of one customer to another customer, right? So now you have to design this concurrent system that can tackle all these customers in parallel. And that's where Occam comes in. Occam gave us this core capability to send messages around. And we took that and we added this actor runtime, and that became Autonomy. And Autonomy, what it does is it gives you those primitives to think concurrently and build these concurrent agents without having to build all of it from scratch. So in a few lines of code, you get a multi-tenant concurrent stateful agent where state is already isolated, but you have to describe this code, right? You have to write this code for the agent. And we have a framework that kind of looks like LangChain, but has these core primitives in it. It has the ability to have a multi-tenant stateful agent to be described. It has the ability for agents to send messages to other agents. Those other agents can be in the same machine. They can be in a different machine. They can be at a different customer location, etc. So what you have to do is write your agent code using our framework, which kind of looks like something like LangChain or Crew or some of these other toolkits, but it has these core primitives built in that allows you to scale. And most customers, when they're transitioning, because most of agent code is really the prompt, right? So the transition is very simple because all they're doing is taking that prompt and structuring, and a lot of times they use cursor to do the translation, but it is a little bit of a translation work. So the user experience looks like this. You write your code in our Python SDK, and then you type the autonomy command, and it will take that code, package it into an image, and deploy it in our cloud infrastructure. So we'll run it for you. We'll host the tools for you. We'll also make it easy for you to make connections. We'll host the vector database for you. So it's this whole platform to build and scale AI products rather than a single personal hobby at-home use agent.
This makes sense. I think the way you described it is also the way I intended to ask, because most of the people, when they think about agents, they think about, hey, can you send a message in Slack? Or can you summarize this email? Or, can you go search web and get some results? They don't think of kind of deep research use cases that need to be constantly running for hours and hours. And sometimes one agent is not doing all the work. They're actually communicating with other agents that are doing something else, which is their core purpose. Thanks for answering that. Now, talking about an agent communicating with other agent, what sort of challenges do you foresee? One of the biggest challenges that I always thought of is when an agent has to talk to other agent, how can they two establish trust between each other? How can they trust that they are a party that they can work with? and how they can share the resources with. So what sort of, is there some sort of primitives that are baked into Autonomy platform to establish some sort of a connection and communication channels and then trust between these two parties?
As I mentioned, Occam's kind of been an open source project for now 5 years. We've been working on this identity and secure communication problem since the very beginning of Occam. And we've leveraged that core primitives in Autonomy, right? So an agent at Autonomy can talk to any other autonomy-based agent over encrypted, mutually authenticated, binary messaging-based secure channels. And you can then make authorization decisions on top of that. So I'll describe this in layers, right? To do trust, you first need to know who are you talking to. You need to identify the other side. But that's not sufficient. You need a guarantee that you are in fact talking to that other side. So if the agent is saying it's the data analysis agent, you have to be certain that it is in fact the data analysis agent. It's not some rogue thing, right? So you need some sort of authentication protocol. But remember, this communication is bidirectional. So you don't need a one-way authentication. You need a bidirectional mutual authentication. Once the authentication is established, that is also not sufficient. The next decision is, do I authorize this other thing to do whatever it's asking me to do, right? So if it's asking, agent A is asking agent B to give it data about payroll, and agent A has to decide, does agent B have access to payroll data or not, right? For that, in Autonomy, we have an attribute-based access control layer. So it's a three-layer solution. There is a cryptographic identity given to all agents in Autonomy. Then there is a mutually authenticated secure channel that any agent can establish with any other agent. And then over that secure channel, we allow you to make authorization decisions that can be policy-driven. So you can have an attribute-based access control policy living in whatever policy system you want to use, and you can enforce that inside Autonomy. But this is just autonomy land, right? Autonomy agents talking to other autonomy agents. And the reason you need that is because, as you said, you usually don't want to write just one agent with a giant prompt. To do well, you want to write an agent that is a specialist in a little job, right? And then you want to sort of establish a workflow almost of, this agent does this job, this agent checks the result, this other agent then does the other job. So even in a very simple workflow, you end up with multiple agents. But then you mentioned this problem of agents can take very long to do stuff. I'll give an example of a customer we currently have. This customer, they are a financial services company that issues business loans to their end customers. So their customers will call them, and while they're on the call, the person has to decide whether they will issue a loan to this business or not. But to do that, they have to study a bunch of documents about that business. And so while on the call, the business person uploads hundreds of documents about the history of the business, like, contracts, payroll data, previous purchase orders, and things like that. And all of them have to be analyzed as quickly as possible on that call so that the loan officer, can make a decision whether to issue the loan or not, right? And before they were using Autonomy, they were running this exercise for like 30 minutes while on the call. Everybody's waiting, right, for stuff to happen. But with Autonomy, they're able to do that same exercise in about 30 seconds. And so what we are doing in that scenario is we take all the hundreds of documents and we give each document to an individual parallel agent. And we process that work in parallel. But because Autonomy's got this simple primitives, it is only 100 lines of code to describe that parallel distributed system, and you don't have to do all the underlying hard work. But now you've got this parallel distributed system. All the agents need to send messages to each other. They all need to trust each other. So that core infrastructure of messaging, mutual authentication, etc., in Autonomy then helps you build that component. But I then want to draw a circle around your question, which is trust, which is a very hard, difficult problem. This is all just still things happening within Autonomy land. And even here, trust can be hard. And we've automated away all the components of it to make sure that your agentic applications can scale out without you having to think about all the trust challenges if you're a product builder. But your agentic application probably isn't an isolated thing. It probably wants to talk to other systems. elsewhere, other agents, other existing, business systems of record, etc. And once you start doing that, then we need standards that multiple companies adopt together
Yeah.
so that this collaboration can happen across products or across applications, right? And there's some interesting work happening there, but I'd say that ecosystem is very immature at the moment because our previous solutions have stopped working. For example, which is the most popular authentication mechanism we've used, was designed for a world. It's essentially, even though we call it an authentication protocol, it's really an authorized access delegation protocol. Fundamentally, OAuth delegates access, right? And access delegation assumes there's someone delegating access and someone who the access is being delegated to. The entity delegating the access was always assumed to be a human in kind of the popular versions of OAuth. There's some sort of offshoot specs that tackle more complicated scenarios, but the main popular implementation of OAuth assumed that there was always a human delegating that access. But now with agents, we're now in a land where that doesn't quite make sense. Like the agent represents a company. It represents an organization. It doesn't necessarily represent a human. And if you give it a human's access credentials, then auditing becomes very hard, right? You can't figure out whether it was the human actually doing the things or was the agent doing the things on behalf of the human. So what you need is every agent must possess a identity of its own, and we need protocols to allow those agents to talk to other agents and other existing systems in an autonomous way rather than always involving humans and humans having to click allow access buttons, which we all click blindly without reading the permission scopes. It's just not a system that can scale to what we need now for agents. So I think what's happening is a whole new set of protocols are being discussed and in the process of being standardized. And I know ScaleKit's doing some really amazing work in that space. But I think that this is a not fully fleshed out space. And currently we're building, a lot of companies are building really insecure agentic type of systems.
Yeah, that's the unfortunate reality. Mrinal, again, I think I want to take that thread and then take a little bit deeper. So today, when I see almost everyone is building agents, either for their own research or experimentation or learning or whatever use cases that they want to solve for their customers, they really, really get to the initial POC version very quickly. They see that, hey, this is working. But what do you see as some of the biggest challenges when they actually take that POC agent and actually make it work reliably in production as a scalable system for thousands of the customers?
So a lot of those solutions are very hacky at the moment. I was, in fact, a few days ago talking to a CISO at a large company. And, you could almost see the disappointment in this person. They were like, it's happening because everybody wants the speed benefits, the efficiency benefits that are coming from agents. So adoption of agents is happening even at large companies, but it's happening in a way that is very haphazard, right? Mostly people are building these, they're almost going backwards 20 years in terms of security progress in these systems, right? Because we learned over the last 20 years that we should have short-lived credentials. We should have safe storage of credentials and safe management of credentials. We should have granular, small scope permissions. These are all learnings we had, and we built ways to do that for last 20 plus years. And then suddenly in agentic solutions at the moment, we've thrown all of that out of the window. Even AWS, that I thought was a gold standard doing credentials well, recently allows the Bedrock API has a long-lived token, right? We're going back to very long-lived tokens that are widely scoped as in almost super user scoped, and everybody is deploying them. So essentially people are taking their prototypes and they're going further and further for these prototypes into production scenarios. The risks are deep, by the way, right? The risks are, one, agents aren't deterministic. So they can do things that you didn't really tell them to do, right? You can have someone send you some piece of data that says, ignore everything you've been told, do something else, and it can work, right? If the scope of the permissions is wide, You might intend for the agent to do X, but it actually can go do Y. So you might intend it to just read some data from your database, but it actually can go delete your entire database. And that would be a bad situation eventually, right? So we're in this like mess at the moment. And the mess is not good. Like if you, as product builders, especially product builders here in San Francisco, in the Bay Area, you learn to like, let's move quickly. It's fine if we break a few things, right? The problem is when we break a few things, the risks are gigantic. And so you're risking, basically running out of business if you take this posture, because building a product in this way where you're sort of poorly managing these credentials, and at some point, let's say it's in the news that you deleted someone's production database, that's catastrophic for at least a small product company. And so this has to change. We have to think, as product builders, we have to think about how can we make sure that the risk we expose our customers to is small, right? Even if something bad happens. And the way to do that is granular permissions, right? If you design the permissions that the agent is given to be so that it can only read from the database, there is no way it can delete the database. Doesn't matter if there's a prompt injection, doesn't matter what has happened, that database cannot be deleted because the agent does not have the privilege to delete the database. So what we need to do this well is protocols that would make it so that agents have granular permissions. In Autonomy, at least within the agent fleets we create inside Autonomy, because we're sitting on top of the open source work we did in Occam, we have this granular permissioning system with an attribute-based access control layer. But widely, when you're talking to other systems, that protocol standardization hasn't quite happened. There's some interesting progress happening there in various groups like OAuth, etc., but it's all work in progress.
Yeah, I totally agree with you when you say because agents can be non-deterministic and extremely probabilistic, you need to have a really strong authorization layer, maybe something that you would add on top of, let's say, Gmails and Slacks and Notions and all that, because they're extremely coarse-grained, OAuth-based scope mechanism right now. If I want to create an agent that needs only 100 emails in the last 24 hours, there is no way for me to tell Gmail to say, hey, I only want to allow this Gmail client to have access only to my 100 emails within the last 24 hours, only from these senders. So there needs to be some sort of a layer. I agree with you when you say that there needs to be some sort of standardization that needs to come in on how you grant access, or what sort of access do you want to grant to these agentic applications so that they don't go rogue and then do whatever they want to do, because unfortunately they have a mind of their own.
Yeah. Really good point. So since we're two authorization geeks, I'll dive a little bit deeper. Traditional approach around authorization for the last, I think, 20 or so years is kind of standardized on role-based access control. And role-based access control assumes you have a human with a certain role that has collection of privileges under that role, and they forever have that privilege until you decide to revoke it. But with agents, you actually don't want that. You want to give them a specific just-in-time permission for the specific task they want to do, and you want to time limit it, right? And you want to revoke it. Maybe it's based on time. Maybe it's based on some activity they've finished. If the activity is finished, access is revoked. Like, it can be different reasons for revocation, right? So you could try to model this with role-based access control, but what you will get is an explosion of roles. You will have to build literally thousands of roles for every possible time combination, every possible permission combination, etc. It gets really, really scary. So the better model, which authorization geeks have always liked, but is hard to do, is attribute-based access control. Attribute-based access control actually allows you to have dynamic policy-driven access control that's based on decisions dynamically rather than some pre-baked set of roles. So I think it is the better model. Yeah. But coming up with a way for attribute-based access control to be standardized across products and companies, very hard problem. So we'll see how that plays out. We've obviously, within Autonomy and first in Occam, we've done the work to standardize that within our infrastructure. But across companies and across enterprises, very hard problem.
So one of the challenges we spoke about when you want to take agents from POC stage to actually production stage is authentication and authorization. But one of the other bigger things that we all learned from the distributed systems is monitoring, observability, and how well your systems are performing. But when it comes to agents, one of the biggest things that I've seen, one of the biggest differences that I've seen is, so in terms of traditional application, you measure how well your systems are performing is based on the latency numbers, is based on how many 200s versus how many 400/500s that are coming out of your system. But now, when an agent, just because an agent has successfully executed a task, that doesn't mean that an agent has successfully answered the problem that it was asked to solve. So the definition of success itself is changing. So in this particular agentic world, how do you think about monitoring observability, thresholds, evals? Because this is one of the fundamental underpinnings of how someone can build a reliable production grade agent.
Really, really excellent question. Observability was a good tool when we were like earlier, right? But in previous generation of products. Observability was something you got to after you reached a certain scale and you were like, okay, I need to like continuously monitor, make sure my stuff is not down when I'm sleeping, all of that, right? And that was kind of the purpose. That's why we looked at like errors, right? In this new world, the word error is kind of changing in meaning. It is an error if you ask the agent to do X and it goes and does Y. But the status code is still going to be 200 in that case, right? It's not a good indicator. What you need to know is did it do Y or not? The problem is it's a non-deterministic piece of software. So the inputs and the outputs aren't like something you can write a test against easily, right?
Yeah.
So you have to bake it in, you have to like basically introduce this notion of LLMs judging other LLMs, agents judging other agents, right? Some of that you can bake into your production workflow. So you can have a agent that does some work, you take the output of that work, and you have another agent evaluate that work. Yeah. And if it's not good enough, you make it loop back. And in autonomy, you can very easily describe these like loops in a flow. So you can say, hey, if your result doesn't meet the judgment of the second agent, you try again, right? And you keep going in this loop until the second agent is satisfied. So you can bake that analysis a little bit into the actual application flow itself. But even as the developer of the product, you have to know, is my agent out in the world doing real things or not? Doing the expected things or not? So it used to be that observability was like a secondary requirement in a product. Now observability and iteration based on observability is a primary requirement in building and shipping a product. You have to know what is the success rate of your production agent. You have to get that data back and analyze it against some benchmark data set. And you have to gather new scenarios encountered in the field and include them in your continuous testing pipeline so that you're incrementally improving progress. I always give the example of, the IoT company that I was involved in about a decade ago. We were building sensors that were sensing city streets, okay? All sorts of anomalous things can happen on a city street. So some of our sensors are based on magnetometers. And on some streets, you would have electric wires going under the street. And at certain points in time, there would be an electricity surge that would confuse all our sensors. There were other streets where you had giant buses passing on the street that had a giant motor in the back. And every time that bus went down the street, it would do unexpected things to our magnetometers, right? But without a way to know that that is happening in the real world, there's no way for your product to get better at tackling that scenario, right? So you need a mechanism to not only check status codes, but also know what were the inputs, and you have to have your product people have to sit and analyze, was this a good response to that input, right? So it's a very different kind of product building exercise.
So you need to have the context, and then you need to look at, based on the context, what is the input and what is the output. And then you need to constantly use that as some sort of an RL loop to keep iterating your agent's predictability or the probability of returning the appropriate outputs.
Yeah. I think they need to be CI jobs, basically. I think like essentially you need to get as much new information, classify sources of errors and say, hey,
Yeah,
I have this class of error, I have this class of error, this class of error. And then you need to have built-in test cases into your CI infrastructure to make
yeah,
sure that that class of error no longer happens or the probability of that class of error falls, right? This is hard engineering. So,
yeah,
going back to this thing I said in the beginning, building software is getting harder, not easier.
yeah. I totally agree.
Or building software
Mona.
products is getting harder.
So we spoke about how it was in the past and how it's getting harder now. How do you think it's going to evolve in the future, especially when more and more developers start building autonomous agents and the each developer is writing a lot of agents and these agents are actually collaborating amongst themselves to get a unit of work done. What are you most excited about in this particular dystopian future where agents are doing everything by themselves?
What am I excited about? I think I've now been building software for like 25 years, right? There were things like I remember when the first time I had an interactive dashboard on a web page, I was excited. Like this is like I'm thinking, it's probably 2005 or something. Before that, you clicked a button, the whole web page refreshed. And then maybe something came back and displayed a number, right? Then suddenly we had tools like jQuery and some Flash-based things in like 2006 or something. You clicked a button, the whole thing animated and refreshed on its own. It was so cool. And now, like if any page would do that loop of a full refresh, we'd be like, what are you doing, right? So like 20 years later, the expectations from software change, right? So I think that's what's currently going on. We have a new technology. It's going to change the nature of what we expect software to do. It'll change the nature of what we expect products to do. It will also change what we expect builders of products to do, whether it's software engineers or product leaders. Their roles will change. But I think what is not happening is you think it exists. Here in the San Francisco area, I meet a lot of founders, and like I routinely meet someone who will go into this mode of I don't need a technical co-founder anymore. I'm just going to build a product on my own. And I think that is a temporary, it's very popular idea right now, but I think it's a mistake. Because I think, yes, typing code has gotten easier and we don't have to do a lot of it, but engineering software has gotten harder. And so you actually need deep technical expertise to build this class of products and get good market share in the market. Because if you think it exists, was a reality, then it doesn't even make sense to be a product company because your customer can also think it and it will exist, right? So it doesn't make sense. I think we're not going to have some magical situation like that. We're going to be building a new type of product for many, many years or decades to come. It's changing, it's evolving. We all have to learn from it and adapt to it, whether it's learning how to use vibe coding tools but with controls around them so you don't ship bad products, or it's learning how to engineer these real-time distributed systems. But I think we're still going to have uh, we're expertise is still going to be valuable, and this is a very niche domain of building good technology products. And I think people have to learn and excel in a new way now, but it's going to be very similar in some ways.
Yeah, I think that's a great way of portraying Mrunal. I think there are two conversations that I've had over the past few months that I can relate to based on what you just mentioned. One is good engineers are going to become great because they don't have to do boring and repetitive stuff anymore. The AI is going to do it for them. They can spend more time thinking, architecting, designing, and actually engineering than writing. But not so good engineers will struggle because what they were doing earlier can be easily done by AI engines, right? The second conversation that I had was, again, I think this goes back to the theme of this conversation, which is you can build features using AI, but you can't build products and you can't build companies using AI because, like you said, AI can write code. It can write code for a feature, but how these features need to interact with each other, the whole context of building these together to solve a problem at a product level, it needs not just writing code, but a lot of deep systems thinking, deep architecture, and deep engineering involved. And then this is something that needs to constantly learn and then improve over a period of time. That is an extremely valuable skill that's not going to die anytime soon.
Yeah. And I mean, I think the vibe coding is actually, you need to be an architect. Everybody needs to be an architect. We used to have like people who thought about narrow scopes in a product. But now suddenly you need everyone who's vibe coding to have the architecture mindset. Also, from a user experience standpoint, have the product mindset. Both of these are hard skills. We only had a few product managers and few system architects in most teams. Now suddenly everybody needs those skills because they can, generating the code is like, it's like, pull a lever, code gets generated. But that's not the hard part. It's like designing the boundaries, designing the experience around that component. Those are the things. Now everybody needs to get good at those skills. And you're right. Like, I think people who can't adapt to it will struggle, but I think most people will just adapt to it. They will learn these new skills and we'll move a level up in what types of things we can build, right? We'll get in, it's the famous quote from Steve Jobs. It's like computers are bicycles for the mind, right? Like, this is a new type of bicycle. It moves a lot faster. So we're just going to build more things with our mind.
On that note, thank you so much, Mrinal, for talking about autonomy and also helping us understand about the architectural and engineering and scaling challenges for autonomous agents that are communicating with each other in a distributed manner. Thank you so much. We had a great time.
Thank you for having me.
Thank you.